Goes away for a bit here, and when you work on your own, I don't mind if you want to listen to something, but for now, I need your attention. Let's review a couple things. Okay, slope. This is pretty basic, but let's just take a second and talk about this. So we have a slope formula, right? Slope m is y2 minus y1 over x2 minus x1. Well, what's the 2 and the 1 mean? When you look at that formula, what are these subscripts, 2 and 1?
That's for the second pair of points in the first pair.
Okay, right. So they're referring to which point we're talking about. When we calculate a slope, we're talking about a slope between 2 points, right? Those 2 points could be on a line, or they may not be represented on a line. Either way, though, we're looking at a slope between points, right? So, for example, and this is, I don't want to make too big a deal out of this, but there is something here that makes life a little easier for you. So if we look at this example right here. So there's the x-axis, there's the y-axis, right? Okay, let's graph these 2 points. What about this first one? Let's graph this. Let's make it yellow. Okay, where is that? Where do I go?
Left 8.
Left 8.
Up 5.
Up 5. Good. So x coordinate, y coordinate. So we go back 8, and we're going to go up 5. So about right there. May not be perfect, but I'll put the coordinates there to remind us. So that's negative 8, positive 5. How about this guy?
Go right 3 and down 6.
Okay, we're going to go right 3 and down 6, so that's about right there. 3, negative 6. And if we're going to find the slope connecting those, we can see that it kind of slopes down from left to right, doesn't it? Okay, it doesn't technically make any difference which of those 2 points you call y1, x1, y1, and which of those 2 points you call x2, y2. Call them point 1 and point 2. But you're going to get the same answer, but it's a little bit better if you choose the first point to be the one that's furthest to the left. Okay, and the reason for that is when we end up doing this formula, it's always good for us to get a positive number on the bottom. Okay, that makes the math a little bit easier. So if we want to get a positive number on the bottom, we always want to choose point 1 to be the one on the left and point 2 to be the one on the right. It'll work either way, but it's just a good habit to get into. All right, so then if we calculate the slope, let's just use the formula here. What does this give us for the slope? We said this is going to be point 1, isn't it? Right? So we'll label that 1, and those are the values of x1, y1. There's point 1. Here's point 2 down here. And those are the values of x2, y2, right? So what does our slope formula give us then? y2 minus y1. What's that? What's y2? Negative 6. It's the y value for the second point, the one furthest to the right. Everybody agree? So we're going to get negative 6 minus, what's y1? 5, okay? Over x1, what's that? Or, x2? 3 minus x1, negative 8. Okay, so if I do that math, what's that going to give me on the top? What's negative 6 minus 5? What's 3 minus negative 8? What happens if I do minus a negative? It becomes positive, so I can just make both of those positive, right? What's that give me on the bottom?
11.
So what's my slope? Negative 1. And I could write it as negative 1 over 1, but if I have a 1 on the bottom, I don't need to put it there, right? Okay, let me show you what that means. That's not hard to do, but let's put that in the context of what we might call a slope triangle. It makes it a little easier, right? If I'm going to have an ant walk from point 1 to point 2, and the ant's going to walk only vertically and horizontally, right? let's always start off with the vertical part. Okay, so how far is the ant moving vertically to get from there to there? Well, he's got to go down a bunch, right? He's got to go down to about there. How far down did he go? Well, he went from a y value of 5 to a y value of -6. It's -11, isn't it? Right? Then the ant's going to go horizontally from there over to there. How far did he go? He went from an x value of -8 to an x value of 3. Right? Isn't that positive 11? Okay, so you see how that works then? In a slope triangle, we're just looking at the rise, which is -11 in this case, over the run, which is 11, and that's how we think about slope, rise over run, right? Okay? So really, that's all this is. In fact, almost a better way to write the slope formula. In that way, works fine. But it's almost easier to just think about it as the change in y, which is the rise. Delta is just like a triangle, right? Delta in math just means change in whatever comes after it. So this is the change in y over the change in x, or rise over run. Okay? Slope triangles are helpful that way. Okay, so we did this guy, right? Let's take a quick look at this one. So, just work down here. So if this is, in this case, the x values are both 9. So which one's further to the left, or does that even make sense? Here it made sense, right? We know that 3 is a bigger x value than -8, so 3 must be on the right, and -8 must be on the left, right? What about here, though, if they're both 9? Okay, the x values are the same, aren't they? So neither one is to the right or the left. In fact, how do they line up then if the x values are the same? Oh, good, they're going to line up vertically, aren't they? Right? Okay, what do you know about a vertical line? Do you remember what the slope of a vertical line is? Undefined. Yeah, let's look at why that is. So in this case, we can't really pick a point 1 and a point 2 that makes sense, so we just pick them randomly. It's going to work. Right, so let's call this one point 1, and let's call this one point 2, how about? So if we're going to calculate a slope then, the slope is going to be y2, so that gives us -8 minus -3, divided by, on the bottom, we're going to get 9 minus 9. Okay, when we do this math, what do we end up with on the bottom? 0. What do we end up with on the top? Who cares? Right? It's just going to be some number, but we don't even care. If I get a number divided by 0, what's that mean? Undefined, right? We can't divide by 0. There's only 2 things, and we'll say this a lot of times this year. One of these isn't going to make a lot of sense right now, because we're not really talking about this topic, but there's 2 things we can't do with real numbers. We can't divide by 0, ever, and we can't take a square root of what? Remember? For real numbers. Can't take a square root of a negative number, right? Or any even root of a negative number. That one we'll hold off on for a while. We're not really going to talk about that stuff for a little bit. But the divide by 0 thing came up here, right? So that's why we say it's undefined, because you can't divide by 0, right? Now what would happen, let me give you one more quick example here. What would happen if we took something like these 2 points instead? Let's say we've got the points 1, 7, and 5, 7. So what's going to happen there? Which one should be... okay, yeah. So this x value is less than that x value, so this would be 0.1, right? This would be 0.2. And what's going to be my change in y then? y2 minus y1, 7 minus 7, right? Divided by, on the bottom, I would argue, who cares? Because what's the top going to be?
0.
And 0 divided by any number is what? 0. Okay. So how do these points line up then? If they have the same y values, what's that tell you? they line up horizontally. Doesn't that make sense? Horizontal line has zero slope, right? Okay, good. All right, so we got all that. Okay, let's talk for a second about graphing lines. Yeah, there we go. Okay, so let's take just a quick review of slope-intercept form. Right, we talked about that a lot. What is slope-intercept form? Not even looking, we all know that, right? Slope-intercept form is what? Y equals mx plus b. What does m stand for? Slope. What does b stand for? What is it again? Start value. Good. It's one way we can say it. Start value or initial value. If we think about it in terms of maybe a little more mathematical, in terms of like the xy plane, what is it? Y-intercept. Okay, but it usually means start value, like in word problems. That's good. Okay, so if we're going to graph a line, and that's what I want to just focus on for a second. There's two quick ways to graph a line, really quick, and sketch a line. Think back to geometry for a second. How do we define a line? How many points does it take to define a unique line? It takes two, doesn't it? If I take 1 point, like that point right there, how many, so right on the end of the pen, how many lines go through that point? An infinite number, right? Infinite number, and you can think of them like, I don't know, what would that look like? You know those, you know those balls that kind of expand?
Yeah.
It kind of looks like that, right? All the little spokes go towards the middle of this thing. Does that make sense? Or like a hedgehog or a porcupine. All the quills would stick out from one place, right? Sort of. Yeah, I mean, kind of get the idea. So infinite lines go through that point, but if I specify another point, I'm going to say that point and this point right there. Out of all those infinite lines that go through this point, there's only one that goes through both. Agreed? Okay. So if we want to graph a line, then the easiest strategy we can take is we just got to pinpoint 2 lines, or 2 points, sorry, and then connect and extend, right? Because that's the easiest way to define that line is with just 2 points. So that's always going to be our strategy. How do we apply that to a situation like this, where we're given a line in slope-intercept form? Okay, let's look at that. So something like this. Everybody agree that's in slope-intercept form, right? Y equals mx plus b. What's the value of m there in this equation? Where would I look to see?
2/3.
It's 2/3, isn't it, right? Because it's always, we're looking for something that's in the form y equals m times x plus b. So m is always the number, it's the coefficient of x, the number being multiplied by x. So m in this case is 2/3, right? Okay, what about b? -1, because we're adding -1 there, aren't we? Subtracting 1 is the same as adding -1. So we end up with m equals 2/3, b equals -1. So how can I get 2 points out of that? Am I given a point?
Yes.
Which one of those 2 pieces of information is really telling me a point? Okay, the -1, b is, right? Because a y-intercept, what's that mean? Intercept means when you run into something, right? So it's where the line intersects what again? Say it again.
Y-axis.
The y-axis. Now, what do we call the intersection of 2 lines? Well, if I have like a line going along that edge of that joint right there, that edge of the room where the wall meets the ceiling, that wall. There's the line up there, right? Okay. What about the line formed by the front of the room and the ceiling? Those 2 lines intersect. What do I call that place where they intersect? It's a corner, but in math I might call that a point, right? The lines intersect at a point. Make sense? So that's a point then. The y-intercept has to be a point because it's where 2 lines intersect. It's where the y-axis intersects with the line, right? So we're given a point right there. B equals -1. So that's the point 0, -1, isn't it? The x value is 0, the y value is -1. Okay, all we need is a second point. Well, how are we going to get that? If we know the slope, how could we create a second point?
Rise over.
Rise over run. Yeah, good. That's what you're saying. So we'll make a slope triangle, won't we? We'll start at this point, and the slope is telling us the rise is 2. So we're going to go vertically up 2, and the run is 3. It's always rise over run, isn't it? So if we run by 3, there's my second point. Got 2 points, I'm done. I just connect and extend, and there's the line, right? Piece of cake. So we anchor it with the y-intercept, and we get a second point through a slope triangle. Okay, what about a different kind of problem? What if we've got something like this? Standard form. This is a little different. You guys probably haven't talked a lot about standard form. Oops. Okay, standard form looks like this. Standard form is written in this form: A times X plus B times Y equals C. Have you used this before at all, standard form in Algebra 1? Raise your hand if you ever remember using standard form. You know, maybe a little bit, but not much probably, right? We'll use it this year. Okay, what are the criteria here? Well, A and B and C are just numbers, but they have to be integers, so they can't be fractions. Right? They have to be integers, and A has to be positive. Okay? We'll talk more about that when we get there. But it might look something like, for example, this. There's an example of a line in standard form. A is 2, B is -3, C is -6, right? Everybody agree? So what are my strategies then? If I take that line, there's a couple things I could do if I want to graph this. How could I use the strategy we just talked about, which apply to slope-intercept form? What do you think? Yes, sir.
Subtract 2x and divide by 3.
Okay, so if you think about this, if I isolate y, so that's the same thing as solving for y, right? If I do that, get y by itself, on the other side, I'm going to get something that looks like slope-intercept form, right? Let's look at that real quick. So if I subtract 2x from both sides, the 2x's cancel, and so I get -3y equals -6 minus 2x. I'm going to change those around, though. I'm going to put the -2x first. You'll see why in a second. And then last thing I'm supposed to do is divide by -3, right? Okay, that works. Then I end up getting my y by itself. Now, what about over here? If I divide the whole side by -3, does everybody agree that's I would call that a common denominator because it's shared by both of the terms in the numerator, right? I can split that apart, though. Okay, and this is a really important thing to remember. I think sometimes people struggle with this idea, is when I divide something like this, the side of an equation, by -3, I can split that up into separate terms. I can, one at a time. So I could rewrite that as -2 over -3 times x minus 6, or I'll make it plus -6 over -3. Well, what's that simplify to? Negative over negative is positive, right? Everybody agree? So I'm going to get a 2/3 x, and -6 over -3 is 2. So plus 2. Yes, sir?
May I go get a drink?
Yes, you may. There's a pass right there. Okay, so now we could do this like we did last time. That's one strategy. What point would I start at? What's my anchor point? Okay, 0, 2, right? So I'm going to start at the y-intercept, and from there, what would I do? Up 2 over 3, make a second point, connect and extend. No big deal, right? We can do it that way. Okay, there's another way, which I would argue is even better. Okay? Remember, all we need are 2 points. Okay, let me ask you this. On the xy plane, what can you tell me about the x-coordinate of every point on the y-axis? So if I take this point, just this random point right here, we don't know what the y-coordinate is because I haven't really specified. Yes, sir?
5 Chromebooks.
Yeah, go ahead. For Ms. O'Rourke?
Yeah.
Yeah, I'm gonna need them at the end here for, well, actually, let's see how many I got. Is it 32?
I just took a guess.
Yeah, I mean, it's gonna be, I don't know, I don't think I can do 5. Mr. Morioka's got some.
Okay.
You could try him to see if he's not using them.
Yeah.
Yeah.
They probably have some.
Okay. I mean, she didn't sign these out or anything, did she?
No.
Okay, gotcha. Okay, so we don't know what the y coordinate is, because I didn't really tell you, but you can tell me what the x coordinate is. What is it? If it's on the y-axis? 0, right? It's got to be 0, because think what the coordinates mean. X and y coordinates just mean if an ant starts at the origin, how far did he walk sideways and how far did he walk vertically? Well, he didn't walk anywhere sideways, right? He only walked vertically. Agreed? So every point on the y-axis has an x coordinate of 0. What about every point on the x-axis? We don't know what the x coordinate is at this. I didn't really tell you, but we know the y coordinate is 0, right? So why don't we do something like this? If we want to graph this thing, let's just find the two intercepts, the x-intercept and the y-intercept, and connect and extend. It's easy to do, right? If I want to find the y-intercept, that's where x is 0, right? So if I let x equal 0, now look at this equation up here. What's 2 times 0? 0. So this, I call this the cover-up term. I can just cover up that term because I'm letting x go to 0. Now look at the simple equation I have left over. If I solve that for y, what do I get? 2, don't I? Good. I divide both sides by -3. So that tells me that when x is 0, y is 2, right? There's a point. If I want to find the x-intercept, I'm going to let what equal 0? Y. So I'll cover up that term. 2x equals -6. What's x? -3. Okay, so then we end up with the point, what was it again? -3. So those are my 2 points, right? All I've got to do is connect and extend. So, there we go. So I get 1 point at 0, 2, and 1 point at -3, 0. Let's get rid of this guy. Right, all I've got to do now is just, oh gosh, this must be kind of funny watching me bumble around up here. There's my line, right? Isn't that a great trick? Set x equal to 0, solve for y to get the y-intercept. Set y equal to 0, solve for x to get the x-intercept. Connect and extend. Yes, sir. Yes, sir. All right, there's pass hanging on the pencil sharpener. Okay, make sense? Okay, try. I'm tempted to just, well, kids, one other thing. I'm going to make this really quick, and I'm going to let you work. I want to get you working. Okay, the last issue is called point-slope form. What's this for? Okay, point-slope form is just a way, if we're given some information about a line, it's a way to come up with the equation of the line. I don't think you guys were taught to use this, though. Tell me if this is right. Like, if we're going to do a problem like this. Let's say we know, right here, we want to write the equation of the line passing through these points. Okay, you can use point slope. But there's another way that I think you've done it. I don't want to change it if you've already done it this way, because they accomplish the same thing. So what would you do if you wanted to find the equation of that line? Find the slope. First thing we need to find the slope, right? Okay, so to find the slope, we already practiced that. So what's our slope going to be? What am I going to subtract on the top? So I'm going to do 4 minus 2 over minus -1, which is 3 plus 1. Everybody agree? So that gives me 2 over 4, which reduces to 1/2. Okay, so I got a slope, 1/2. I need to find, if I want to put this in slope-intercept form, which is usually what I want to do, right? If I want to put it in slope-intercept form, then I need the y-intercept, right? So if I write the equation out, y equals mx plus b. The m and the b are the numbers I have to plug in, right? X and y are the variables. Everybody agree? We got to be able to plug in values of m and b, though. Those are the parameters. You can kind of think of them like dials. If I dial in a value of m and a value of b, I can create any possible line. All of the infinite lines in this plane I could specify by just dialing in those two values, right? Well, I know what m is. We already found that m is 1/2, but we need to find b. We could just borrow a set of points, an x and y value from up here, couldn't we? Okay. Now think why that works. If we talk about the equation of a line, like for example, if we go back for just a second to, how about to this line, where did we get an answer here on this? Didn't we do one up here? We wrote down an equation in slope-intercept form? I thought we did. Maybe not. Well, here's one right here. How about? Okay, good enough. Here's an equation of a line. What does this do? What does this thing do? If I pick an x value, like let's say I pick an x value of 10, and I want to find the corresponding y value, what could I do? I could plug in 10 for x, couldn't I? Everybody agree? And solve for y? Okay. What if I pick an easier value? What if I pick a value like 3? If I pick x equals 3, then 2/3 times 3 is 2, plus 2 is 4, right? Would you agree that's a point on the line? Okay. That's a solution to this equation. Because what does a solution do to the original equation? What's the word we talked about last week? Starts with an S. What is it? S-A-T. What is it?
Sat.
Sat. That's the start of it. You don't remember? We looked at simpler examples last week. We looked at things like, I might have said this. 2x plus 1 equals 11. So I would subtract 1 and divide by 2 and get x equals 5. Agreed?
Satisfies the equation.
Good. That's the value that satisfies the equation if I plug it in. Everybody agree? Right? Does that make sense? Okay. Well, this is harder, right? Because now I've got two variables, right? So a solution has to be both an x and a y value. Okay, make sense? Well, in this case, we know that if we pick 3 to be the x value, the y value that goes with it is 4. How do I know? Because if I plug those back in, they work. They satisfy the equation, right? Does any old value of x and y work? No. If I pick, for example, 3 and 5, 3 for x and 5 for y, it won't work. That's not going to work. Is that a point on the line, do you suppose, then? No. Each of the solutions, the x and y values that satisfy this line, corresponds to a point on the line, right? Now you got to really, this might seem, really think about this, because this is pretty deep. This will help you think about algebra. How many points are on the line? If I think about each point as a little beat on the line. How many are there total on that line? Infinite, right? There's an infinite number. Every one of those points on the line has to have a place in the xy plane. It has to have an x and a y value that satisfies this equation, right? Well, let's pick another one. We're picking convenient ones, but I could pick decimals or fractions also. What if I pick the value 6? I'm just going to pick 6. I'll make them easy. Well, 2/3 times 6 is what? 6 over 3 is 2, times 2 is 4. Everybody agree? 4. So 4 plus 2 is 6. So there's another point that also lies on the line. I could keep going. There's an infinite number of them, right? Every one of those points is a value of x and y that makes this true, right? So does it make sense then that when we write an equation of a line like this, x and y are variables? I can change the value of x by moving along the line, and when I do that, I'm changing the value of y, aren't I? Right? This line looks like, if I go up 2, and then I rise by 2 and run by 3, there's my next point. Right? So there's my line. We know that. As an ant walks along this line, he's changing his x value, but the y values are changing also, but they have to be the y values that work in this equation, right? So x and y can vary based on this equation. Does the 2/3 into 2 vary? No. That defines the line. No matter where you are on this line, the slope is always 2/3, and the y-intercept is always 2. Does that make sense? So you can see why x and y are variables, right? Okay, so back to our issue here then. So we know that the slope is 1/2. We don't know what b is, but we know that these are examples of solutions. These are points that are on the line, so they're x and y values that have to work, right? So why don't I do this? Why don't I take one of these and plug it in, right? If I plug in an x value of -1 and a y value of 2, oops, that has to work, doesn't it? Right? Has to. That's a point that's on the line. So what do I get then? I get 2 equals 1/2 times -1 plus b. I can solve for b then, right? What's 1/2 times -1? Okay, so I get 2 equals -1/2 plus b. What do I have to do to solve for b?
The other side.
Well, if I'm just trying to isolate that, don't I just have to get rid of that term? So I'd add it to both sides, good. So I add 1/2. So what's that give me? What is 2 is how many halves? So if I add this up, in other words, 2 plus 1/2, that's 2/1. What do I have to do to top and bottom to get a common denominator? Got to multiply. I need a 2 on the bottom, don't I? So I've got to multiply both the top and the bottom by 2. So that's going to give me 4/2 plus 1/2 is what? So look, now I've got B. I know what that dial is. I've got M. I know what that dial is. And so I know my answer, right? My answer is just y equals, what was the slope, 1/2? 1/2 x plus 5/2. Does that make sense? How do we do it again? We solve for m, and then we plug in the x and y values from one of those points to find b, right? But then we have to write it in terms, our final answer, we got to put the x's and y's back in, right? Make sense? Okay, that's a lot. We're done. Grab a Chromebook. How much time we got? Oh, man, that took too long. Okay, I'll let you work tomorrow. How's that?